I think I can't show the ripple moving up and down. It just understood everyone I think has seen. So these are ripples. Okay, these are some on that. What is that gray or say like a dark color round circles? They are called as ripples here. So we can see, and a surface wave will propagate. How do the surface will propagate? The surface wave will propagate in this direction. The disturbance will propagate radially outward. Am I right? So what is that arrows? What do that arrows indicates? What is the ripple? Oh. What is the ripple? These are ripples. Huh? And what do this arrow? This arrow indicates direction of. Okay, now look at, shall I say we have disturbed, the lake was calm, it was calm. That one, the moment you throw a stone, if the stone is dropped here at the middle of the lake, then we see the disturbance. No, shall I say that we disturb the surface of a lake? I'm using word disturber because usually the disturb word what we say, hey, don't disturb me, like this, it's a negative one. No, something, the word what happen implies the negative thought. Don't disturb me, negative emotions. So here the same word disturbance I'm using. Shall I say that I disturb the medium of the surface of lake, or how the particles on the surface of lake wants to be? They just want to be calm. Means like they want to lie in a plane. They'll be at rest. When you drop a stone, so what happen? The particles on the surface of a lake, what happen? They'll get disturbed. Will they move? Next question. The particle which is here, will they move? Say, I think, sir, lake pond, where to go? Need not you take any some bucket, you take it, bucket, you take it, fill up water, leave it for 10 minutes. Okay, the level will become exactly, it will become leveled water and there won't be disturbance. Drop some any object at the center. Then you can see the ripples. Okay, at the same time, I'll ask you to drop some, keep some paper on it. Some red color here, one blue color, one red color, one green color. Drop a stone at the middle of this one. Then what actually you notice, you start seeing that the papers which are floating, they'll start moving up and down. Am I right? Or will that papers which are floating up and they'll move away from the center? No, they'll be there only, they'll be vibrating, no, up and down. And you can see some sort of disturbance propagating, the surface wave propagating. This is what happens here. So what will happen to the particles that are lying on the surface? So what do you mean by particle? Molecule in terms of chemistry. So here in physics, we'll call particles. The particles here, best example of particles means the papers which are floating on the surface of a water. What will happen to them? They'll just start vibrating up and down. But what will happen? The disturbance what we have created, that will propagate. So what do you mean by disturbance now? Anybody? See, when you drop a stone, the stone what happen will get into the water with energy, no? And that energy what will happen now will propagate here. So here disturbance propagating means, shall I say, some sort of kinetic energy of some stone will be given to the water and that energy starts flowing radially outward. What will happen to points on the surface of a lake? They will not move. They will move vertically up, but it will move like this. So direction of propagation of what? Direction of propagation of wave, or nothing but energy, or disturbance propagates. So therefore, what is a wave? How I'll define the propagation of disturbance from one point to another point is called as a the wave propagation. See, this is something very troublesome. So disturbance, yes, yes, it is that one. So how to disturb this surface of a lake. You just drop one object, it's the particles there, they'll get disturbed, and the disturbance will propagate. The disturbance will propagate here radially. The disturbance propagates. Okay, fine. This is the way what we define. Okay, now let's take the types of waves. First, we have mechanical wave. Hmm. So, what do you mean by mechanical wave? It's a it's a wave in which a material medium is needed for its propagation. A material it needs a material medium for its propagation. There is a mechanical wave. Hmm. Non-mechanical doesn't require any material medium for wave propagation. Okay, doesn't requires any material medium for wave propagation. Like this, what happened? We have that one. Mechanical wave example. Uh, okay, several examples are there. I'll put it sound wave. Sound wave, we look at. Can we speak in vacuum? Not possible, no? Sound wave cannot propagate. Then wave on a string, wave on a rope. Then surface wave on water. Several examples are there. Non-mechanical wave is EM wave, electromagnetic wave. Okay, this we will study in the that is nothing but sound wave, no?
Yes, sir.
There's nothing but sound wave. Okay, we will study this particular non-mechanical wave in the next part of the chapter. Like EM waves, there we'll discuss. So our focus will be now, our syllabus will be more about the mechanical wave. So again, this particular waves, what happened? We have the types here, longitudinal and the transverse waves. Transverse waves. So what are transverse waves? The particles of medium vibrate perpendicular to direction of propagation. So suppose say if a wave is propagating like this. So what is that arrow? Direction of propagation. How the particles of the medium they'll vibrate here. So what is that? This arrow? Direction of propagation of wave. And these are motion of particle. Direction of motion of particle. Okay, this one. So this is about the transverse wave. What about the longitudinal wave? The particles of medium vibrate along the direction of wave propagation. This one. So how the particles here? So it will vibrate in this way. So time being, I'm just giving. So we have to go. One chapter itself is there on transverse wave and longitudinal wave. It's just only an introduction. So again, as usual, what do that arrow indicates? Direction of propagation. And the red color arrow indicates the particle will move along the x-axis. The wave propagates along x-axis. Here the wave propagates along. Wave means here what happened? Energy or disturbance. The energy flows along x-axis. Particles vibrate along y-axis. Here energy flows along x-axis. Particle will vibrate along x-axis. That's the meaning of longitudinal. The particles of medium vibrate along the direction of propagation of a wave. Direction of wave propagation. That's called like a longitudinal wave. Okay, what is our syllabus? We are going to discuss only mechanical wave. The two, our syllabus is confined to two types. One, mechanical transverse wave, the first one.